Hi all, my name is Sandhujan. Today we are going to talk about the non-production AI systems. As we know that artificial intelligence is transforming in the world, and the non-production systems are essential part of the AI landscape. Today we are going to discuss about the three main non-production systems in detail. Let's move on to it. Let's have a brief introduction on the non-production systems. As we know that the artificial intelligence has revolutionized various industries, enhancing efficiencies and enabling groundbreaking achievements. While the majority of the discussion focus on AI in production systems, there is just another crucial phase, the non-production AI systems. These systems serve a vital role in the AI development lifecycle, encompassing everything from research and experimenting to testing and validation. The non-production AI systems refer to environments and frameworks where AI models are designed, trained, and evaluated before they are developed into real-world production scenarios. When we talk about the non-production system architecture, we are focusing on three main non-production system architecture. One is a decision tree architecture, second one is a neural network architecture, and the third one is blackboard system architecture. Let's go deep into it. Now let's have a look on the first one, that is the decision tree architecture. Decision tree architecture is a powerful tool for data analysis and decision making. In this presentation, we will take a closer look at its components, learning process, running techniques, and real-life applications. Let's get started. When we talk about the decision trees are simple yet effective way of representing decisions and their consequences. They are widely used in fields like finance, healthcare, and marketing. Next one is the benefits of decision trees. Decision trees can help identify important variables, predict outcomes, and reveal relationship between variables. They are also easy to explain and understand. Now let's talk about the drawbacks of decision trees. Decision trees can be complex, which is prone to overfitting and sensitive to small changes in the data. They also require careful pruning and validation. Now let's talk about the components of the decision tree. First one is a root node. Second one is the indent node. Other one is a decision node and leaf node. Let's talk about the root node. The root node represents the entire dataset and the starting point of the decision tree. It is a first decision point that determines which feature to split on. Next, we talk about the internal nodes. Internal node represent the decision criteria and the splitting point for a feature. They divide the data into smaller subsets based on the features values. Next, we talk about the decision tree. The decision node represents the outcome of decisions and led to subsequent nodes. They indicate which branch to follow based on the feature values. Let's we talk about the leaf node. Leaf node represents the final outcome or classifications of the decision tree. Now let's have a clean idea on the understanding of the decision tree learning process. There are many four steps. One is a data collection, second one is a data preparations, then the model is selected, and the final one is a model fitting. When we talk about the data collection, the first step is decision tree learning is collecting relevant data and identifying the outcome variable to predict. Second one is a data preparation. The second step is preparing the data by cleaning it, handling missing values, and selecting relevant features. The third one is a model selection. The third step is selecting an appropriate model such as ID3, C, 4.5 or CARD based on the problem type and data. Next one is a model fitting. The fourth step is fitting the model to the data and creating the decision tree based on the selected fitting criteria and the pruning technique. Next, we are going to explore the decision tree pruning techniques. First one is the complexity pruning. This technique involves adding a complexity penalty term to the splitting criterion to avoid overfitting. It balances the tree size and predictive accuracy. Next one is a reduced error pruning. This technique involves removing branches that do not improve the tree's performance on the validation set. It optimizes classification accuracy and tree size. Now let's talk about some of the applications of the decision trees. We can use the decision trees in finance, healthcare, marketing. In finance field, the decision trees are used in credit scoring, loan eligibility, and investment decisions. In healthcare, decision trees are used in disease diagnosis, treatment, selections, and patient risk assessments. And in marketing, also we are using the decision tree for stock marketing recommendations, product recommendation, etc. Now we are going to discuss about the second type of non-production system architecture, that is the blackboard system architecture in AI. When we talk about the blackboard system architecture in AI, the blackboard system architecture is a flexible and accessible way of building AI systems. By using this approach, we can easily integrate different knowledge sources and domains. Let's dive deeper into the architecture and its components. When we talk about the components of the blackboard, we can talk about the blackboard. There is a knowledge sources, there is a control knowledge and domain knowledge. When we talk about the blackboard is a centralized data structure that holds information processed by independent knowledge sources. It acts as a reservoir of problem-solving information. When we talk about the knowledge sources, modules responsible for performing specific tasks such as data processing or inference. They operate on the information present on the blackboard and update it based on their results. Next one is a control knowledge. It manages the flow of control between knowledge sources by selecting appropriate one at any given time. Next one is a domain knowledge, which is contains information about the problem domain being solved. Next, we can talk about the inference engine. We are going to discuss about what is it, how it works, and the program. When we talk about what is it, the inference engine controls execution of knowledge sources and manages the blackboard structure. It decides which knowledge source to activate next based on a set of predefined conditions. How it works? It gathered information from the blackboard and feed into the appropriate knowledge sources. The knowledge sources then operate on the data and update the blackboard structure with the results. That's when we talk about the programming. The inference engine is typically programmed in a domain-specific language and designed to conform to a special architecture requirements. Now let's talk about the user interface and its advantages. When we talk about the user interface allows interacting with the Blackboard systems. It accepts input from the user and presents outputs generated by the knowledge sources. Now let's talk about the advantages. When we talk about the advantages, the Blackboard system architecture is flexible, extensible, and allows knowledge sources to be added or removed without affecting the end systems. Additionally, different domains can be modeled within the same. When we talk about the knowledge sources, expert system is the first one. These knowledge sources are all based on the systems that mimic the decision-making ability of a human expert in a particular field. This one is a data mining. By analyzing the existing data, these knowledge sources can identify trends and patterns that can be used to make predictions and generate new data. Next one is a fuzzy logic. When we talk about the fuzzy logic, these knowledge sources are used to handle imprecise or uncertain data, allowing more flexible and balanced approach in decision making. Now let's we talk about the control knowledge and its importance. The architecture. Control knowledge is responsible for managing the flow of control between the knowledge sources. It acts as an orchestrator deciding which knowledge sources to activate based on the information present on the block. Management. Control knowledge plays a crucial role in keeping the Blackboard system organized and efficient. It also ensures that the decision-making process is transparent and follows a logical path. When we talk about analyzing the result, by analyzing the pattern of interaction between the knowledge sources, control knowledge can provide insights and also they can suggest improvements. Next one is the domain knowledge, which is the head of the system. The main components are the knowledge about the problem domain and its requirements. Second one is the ability to represent this knowledge in a language that the Blackboard system can understand. And the importance of this domain knowledge is that the domain knowledge provides a structure and the context to the problem solving process. It allows knowledge sources to operate more efficiently and provides clearer guidance to the interface engine. Next, we are going to discuss about the neural network architecture in artificial intelligence, which is a backbone of the AI systems. Next, we are going to explore a uh, few working of the neural network architecture and its components. Now, let's discuss on the neural network. The definition. A neural network is a type of machine learning that is a model after the structure and function of the human brain. The functionality is it uses complex algorithms to recognize the patterns and make predictions based on the large amount of data. When we talk about applications, neural networks are used in a wide range of industries from healthcare, finance to entertainment. When we talk about neural network architecture, it is having three layers. The first one is input layers. The input layer receives data from the outside world. The second one is a hidden layer. Hidden layers process the data through a series of complex calculations. The third one is output layer. The output layer provides a final result of the neural network analysis. There are mainly different types of layers in neural network. First one is a convolution layer, which is used in computer vision to extract features from images. The second one is a recurrent layers, which is used in natural language processing to analyze the sequential data. Third one is a pooling layers, which is used to reduce the size of the images in a neural network. As we are going to talk about the activation functions in neural networks, first one is a sigmoid function, which is used in binary classification tasks, such as predicting whether an email is spam or not. Next one is the ReLU, Rectified Linear Unit, which uses an image recognition task to improve the accuracy and speed up learning. The third one is a Softomax, which is used in multi-class classification tasks such as identifying different types of animals in a photo. Talk about the architecture of popular neural networks. The convolutional neural network, that is a CNN, which is used for image recognition tasks by scanning an image and identifying specific features. Recurrent neural network, that is a RNN, which is used in natural language processing tasks by analyzing sequential data. Next one is a deep belief network, DBN, which is used for unsupervised learning tasks by identifying patterns in a data without external labels. Now let's discuss about the applications of neural network architectures. First one is a computer vision. Second one is a natural language processing, and the third one is a finance. When I talk about the computer vision, which is used in self-driving cars, facial recognition, object detections. When I talk about the natural language processing, using speech recognition software, chatbots, and language translation programs. When we talk about the finance, it is used in fraud detection, risk management, and predictive modeling. These are the some of the applications of the neural network architectures. When we talk about advantages, new architecture and algorithms are being developed that will improve the accuracy and speed up of learning. When you talk about the limitations of the neural networks, neural networks require vast amounts of data and computing power, which may not always be available. In conclusion, the non-productive AI systems are pivoted for AI development, providing a safe space for innovations and refinement. Key architectures include decision tree, offering transparency and explainability, the neural network driving cutting-edge breakthroughs, and blackboard systems. These environments empower the researchers to fine-tune models before a real-world deployment. Their significance lies in propelling AI progress while ensuring reliability and high standards. Continued investment promises transformative potential, enriching industries and lives globally. Thank you for watching my video. Have a nice day.